Hi guys, this is your Chapter 7 practice test review video for apparently what is the practice test from hell, because it is 10 to 12 and I never ever want to see this practice test ever again. But I'll save that story for after spring break. For now, let's just get through this practice test, hopefully. First three have to do with inverse functions, inverse sine functions. So for number 1, we're looking for the inverse sine of a radical 3 over 2. So the inverses are not the reciprocals, it's not the negation, it's talking about, like, here's the ratio, what angle matches up with that ratio, where sine just says, here's my angle, what's the ratio? So this is like a swap x and y situation. So we're looking for sine, that angle that would give me a radical 3 over 2, and on my unit circle, the sine are my y values, and you see I have 2 marked here, the 60 and the 120. For number 1, they're going to, and for number 2, they're assuming that you're starting here and you're working your way up around the circle, and so the first one I hit is that pi over 3, and that's why that's the one that's the correct answer, not over the 2 pi over 3. Same issue with the tan of the negative 1. We're looking for the angle that would give me a tangent of a 0. And tangent is y over x, or sine over cosine. And since we're dealing with a unit circle, that would be y over x. So I'm looking for 0 over a number. And 0 over a number, the first place it happens is right here at 0. So 0 degrees, which is the same thing as 0 radians. For number 3, this is one of the two that we're going to talk about that really have some issues, in that if you have a tangent and you say find the tangent of this angle and you get this crazy looking number, which we will in a second, and then you do the inverse tan, it should bring you back to the original. There are these things called reference angles, which we really haven't talked much about yet in trig, and for some bizarre reason, without any kind of warning from the directions, we use the inverse angle as our correct solution, instead of the one that makes the most sense, which is C. I'll show you how they got the other one, but I will take either correct answer. I'll just have to go in and override your question for number 3 if you chose the one that actually makes sense. I took that 3 pi over 5 and I changed it to degrees, and it's 108. The tangent of 108 degrees, and my calculator's in degree mode to get this to cooperate, would give me a tangent of a negative 3.07 blah, 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 blah. When I take the inverse of that tan and I say, what angle would give me this tangent? I don't get back 108. I get back the 72. And 2 pi divided by 5 is 72, oddly enough. I think it needs to be in radian to get it to do that. And if I say angle, it's 72. I don't know why it's not cooperating for me at the moment. And negative 72. Negative 2 pi over 5. That's negative 72. So they have the correct answer as that negative pi over 5. Logically, of course, it should be the 3 pi over 5. So that's one that you're going to want to watch out for, but I will fix for you after we get back from spring break. Then the next quite few of them actually are really much more straightforward. For number 4, we're looking for the inverse. So when you want to find the inverse, you swap x and y. We're going to solve for y. So add the 2. Divide by 9. We undo the sign by taking sine inverse. And so inverse is sine of a x plus 2 all over 9. That's equal to y, and that's my inverse function. For number 5, there's an easy way to do it and a hard way to do it. We did the hard way in class, but on your calculator, you can graph this, and you will get a function that goes like this. Right? And it's a little hard to see. The 7x will make this go super fast, so you'll get 7 rotations within a 2 pi. What we're looking for right here is the amplitude. So I'm going from -3 to +3. Negative, so I start upside down. My original function, my original sine function for sine and cosine, the domain is all real numbers. The range is set by the amplitude, so I'm going from -3 to +3. And what it asks is, what is your domain of not only your original, but the domain of your inverse? And remember, the domain of your inverse is the range of your original. So you're just going to swap the domain and range. So the domain of my original is all real numbers. The domain of my inverse is the range from the original, which is a -3 to a 3. 6, also pretty straightforward. We'll divide both sides by 4. So I have inverse cos of what angle would give me a pi/4. So I take the cos of both sides. And conveniently, I say, all right, let's find the cosine of pi/4. Cosine on my unit circle is the x. So x is radical 2/2. 7, pretty similar. Divide both sides by 2. I get inverse tan of x is equal to a -pi/2. Take the tan of both sides, so that way those undo each other. I'm looking at tan of a -pi/2, which is the tan of a -90, so I'm down here at the 270. And tangent is y/x. So a -1/0, can't have a 0 in my denominator, so that's undefined. We're not going to be able to solve this. 8, I'm looking for the inverse cotan of a radical 3. So what angle would have a cotangent that's a radical 3? So don't get caught up on this notation. It's just saying like angle question mark, cotan of angle question mark is this. Well, that means the tangent of angle question mark is the flip of that, because cotan is just the reciprocal of tan. And the tangent of angle question mark, if I rationalize the denominator, is a radical 3/3. Calculator in degree mode was what that scribble scrabble says right there. If you put that in, because what degree mode says is not so much what you get out, but it's going to read what you type in as a degrees and says, well, okay, and we'll put it out in a degree as well. So I'll say inverse tan of a radical 3/3, and I'll get 30, which is pi/6. Do you ever get like a crazy looking number? That means it's in radians. And the degrees are always like nice, and the radians are always crazy looking. 9 is a simplified, and we're going to start off with foiling this mess right here. So 1 times 1, of course, is a 1. I'll get a negative cotan, a positive cotan. Those guys will add out. Negative cotan squared, and then I got this cosecant squared floating around out here. So remember, sine squared plus cosine squared is a 1. If I divide everything by a sine squared, I'll get 1 over a cotan squared over a cosecant squared. And if I kind of flip these two, like subtract the cosecant to the left and subtract the cotan to the right, I get this, which works out well because anywhere I see that, which I so conveniently have 1 minus the cosecant squared there, I can take that out and shove him in instead. So I get a negative cotan squared minus another cotan squared, or plus a negative cotan squared, and that would be -2 cotan squared. And then here's 2 more of my least favorite questions. Well, actually, number 10 is not so bad. Cosine double angle. Sine's a 4/5. I'm working on a 0 to a 2 pi. Very important to remember that, which reminds me I need to change that. If sine is 4/5 and sine is opposite over hypotenuse, I can use Pythagorean theorem to find x. So 3, 4, 5 triangle, which means the cos of that same theta is adjacent over hypotenuse, or 3/5. And then you get like 3 or 4 different double cosine angle formulas you can use on that sheet. I chose the first one. So cos squared, original cos is 3/5, so 9/25. Minus the sine squared, the original sine squared was 4/5, so minus 16/5. And so that's how you get a -7/25. The catch with number 11 is this pi to a 3 pi over 2. That is what's very important. It's saying, look at the angles from 90 to a 270. So just like that, Western Hemisphere, if you will. You don't look at from 90 to 0 and the negative 90. Don't even go over there. And you'll see why in a minute. It's saying, all right, your tangent is 12 over 5. So find the cos of theta halves. Well, tan is y over x, or it's going to be sine over cosine, right? So here's my sine, here's my cosine. Again, I can use Pythagorean theorem, and I get my radius being a 13. So that means my original cos was a 5/3, but here's where the little snag comes in. I see, oops, you have to think about where this angle is landing. It's saying, okay, first of all, you're not going to look here, and you're not going to look here, because I'm going from, was it pi or pi halves? From pi to a 3 pi over 2. So like we don't even need this right here. So we're talking about stuff only in this little region. And you can see I had written here that A, S, T, C, all students take calculus. And that's why this was so important about this restriction. The all means all my functions, my trig functions are positive here. Here only my sine is. Third quadrant, if you will, only the tangent is. And in the fourth quadrant, only the cosine is. So when you are looking at this angle, we have to think about where this thing is landing. So since I'm down here, yeah, my tangent is positive, but only my tangent is positive, which means that this wasn't really a 12 and a 5, but a negative 12 and a negative 5, because negative 12 over negative 5 would bring me back to a positive 12/5. So you take your cosine theta halves, and it's a positive or negative, square root of 1 plus the original cosine, which was a negative 5 over 13, not a positive. And when you get this to be a 13 over 13, right, get a common denominator, then you'll get 8 over 13 over 2, which is equivalent to 8 over 8, 26. Divide both of them by 2, right? I can simplify, so I get 4 over 13. So I get a positive or negative 2 over a radical 13. But remember, we're talking about a cosine. And the only thing that could be positive is tangent, because we're wedged in down here. That's why it was so important that you knew you were in this quadrant. Because if we were here or here, anything, you know, it could have been here or it could have been here, if it was from 0 all the way over. So I'm talking really about the negative version, not the positive version, because in this quadrant, it's got to be a negative. And if I rationalize the denominator again, negative 2 radical 13 over 13. If you did not look at it and you had to pick, like if you thought it was from 0 to here or pi over 90 to here, if you were to follow this over to the other side, you would have gotten a, I think it was 3 radical 13 over 13, which would just be like the flip going through that origin to the other side. So it's like an equal but not quite equivalent situation. And that's the other tricky one that I was talking about. 14 and 15, I got this mess is a sine of an 8 theta times a cos of a 4 theta. You're going to want to use those formulas. We want to change this product over to a sum. So 1/2 sine of alpha plus beta, so 8 plus 4, plus the sine of alpha minus beta, so 8 minus 4 theta, and that's your answer. Take the sum, which in this case a difference, and change it over to a product. So I get negative 2 sine the sum of those two divided by 2 times a sine of the difference of those two over 2. So 8 over 2 will give me a 4, so a negative 2 times sine of 4 theta, and 4 over 2 will bring me down to a 2, so then times sine of 2 theta. So those are just straight formulas from the sheet. 16 is really not so bad to solve. Subtract these 6 over, you get a negative 1. Divide by 2, I get a cos of what angle will give me a negative 1/2, and we really don't even need to use my inverse cos because I could just look here, and I'm looking for where do I have a negative 1/2. Where do I have a negative 1/2? Right there at a 2/3 and a 4/3 pi. And so those are my two possible answers. For the equations, we'll take either. For the simplifies, they just took whatever the first one was in the line. All right, so here is the other very strange one. Tan of 2 theta, and I have a green arrow over the 2 because this is what's going to have a big effect on these answers down here. We know that we're going to do inverse tan, and if I do inverse tan, he goes, right? So I just have the 2 theta, and I'm looking for where is my tangent of negative 1. Tangent is sine over cosine, so anytime the two are opposites, so the same number, opposite signs, that's where it's going to be a 1. So I got one right here at a 135, and then through the looking glass over here to a 315. So it would be very tempting to think, all right, so I have these two, so it's 2 theta is equal to the 3 pi over 4, or an and, 2 theta is equal to 7 pi. When you divide by 2, I get 3 pi over 8 and a 7 pi over 8. And the answer key says, but there's 2 more. And there's 2 more because we're thinking about this as rotations through the circle, if you will. So I have this, and it says, all right, like, make a pass through the circle. At what angles does this happen? Well, we know from the first pass in the circle, it hits here, bing, and the second pass in the circle happens again here, but then don't stop, keep going again. So on your second round, when you go through again, you hit it again. But this angle is technically not 3 pi over 4 anymore because I already went through this 2 pi one round already. So this is my second round of 2 pi. It's kind of like on the tidal wave thing, like it was 3 a.m. on a Monday, and it was 3 a.m. on a Tuesday, but if you use that twice, you couldn't get that sine curve to work out because it stopped. You know, you wanted to show over a 3-day period. So we had to use those military hours and then add on the 24. Same thing here. This 3 pi over 4 already happened. So it's like an AM and a PM situation that I got to add the rotation on. So I have a 2 pi that I already completed plus this extra. And we need a common denominator, which is a 4. And that is how you get the 11 pi over 8. And when you come around here, it's not just 7 pi over 4 anymore. We already have 2 pi worked in, so I have to add in that extra. So I have 7 pi over 8 plus the 2 pi that I had already lopped around before. Oh, I'm sorry, 4. Common denominators of 4. And that is where the 15 pi over 8 comes in. On your test, I believe that 2 theta is a 4 theta. So instead of having, so like if you had 2 answers in 1 round, in 2 rounds you'd have 4, in 3 rounds you'd have 6, so in 4 rounds you're going to have 8. And that should help you figure out which one is going to be your right answer for number 17. So you don't have to do it all out, I guess. 18 and 19 are a breeze compared to some of the other strain ones we have. What you want to remember with trig equations is we can't divide them away, because if you divide away the ratio, it's like you just obliterated the whole angle. And we don't want to get rid of the whole angle, it's just that those ratios repeated, if you will. So what we want to show the repeat. So instead of dividing by sign or moving this over, anything like that, I'm going to factor a sign out. So sine times sine will give me the sine squared times the 1 will bring me back to that. It's set equal to 0. So either sine of theta is a 0 or sine of theta plus 1 is a 0. So where does the sine of theta 0? Well, we already saw this at 0 and pi. Well, where is the sine of theta? Subtract the 1 over a negative 1. It's only right here, right, because you're talking about the y value, and that's why you have 1, 2, 3 answers in your t. If I plug either one of these 3 in to the sine squared theta plus sine theta, your outcome is going to be a 0. 19, a little bit more involved. I don't think it was this long on the actual test. I got this cotan theta equal to a 2 cos theta. So let's drag this cotan over, change it to a cosine over sine. Factor out a cosine. Cosine times 2 will give me a 2 cosine. Cosine times a 1 over sine would bring me to that cotan. So now either cosine of theta is equal to a 0. So where's your cosine of 0? Where your x's are 0. So here are the pi halves and a 3 pi halves. I'm going to add over this 1 over sine. Now 1 over sine is secant. And if 2 is equal to what a secant is, and secant is the flip of sine, if you flip this guy over, you can flip this one over. So flip over the secant, you get a sine. So much like we did with that cotan and the tan, flip the 2 over, you get a 1/2. Well, where is your sine value, which is a y, a 1/2, right here and right here at pi 6 and 5 pi over 6. And so 1, 2, 3, 4 different angle measures. If I plug it into my original, my outcome will be a 0. Or actually this very original, that cotan of like say pi over 6 would be the equivalent ratio of 2 times the cosine of that pi over 6. And that is your test. I would say be careful with your degree and your radian on your calculator. If you get a number that doesn't make any sense, move it over to your degree mode because it's in radians. Worst case scenario, bust out a piece of paper and do it by hand. To convert from degrees to radians, take it and measure, multiply it by pi over 180. If you want to take that radian and you want to make it into a degree, multiply it by 180 over pi. Sometimes it's just easier to type it in by hand. Good luck.